The ticking star, the tale of Betelgeuse. In a vast tapestry of the night sky, where countless stars gleam like scattered jewels, one star burns a peculiar ruddy glow, commanding attention from astronomers and stargazers alike. Its name is Betelgeuse, a red supergiant nestled on the shoulder of Orion, the Hunter, a constellation that has guided humanity's gaze for millennia. Known to some as Alpha Orionis, Betelgeuse is no ordinary star. It is a cosmic titan, a stellar giant nearing the end of its tumultuous life. And its story is one of beauty, mystery, and the promise of a cataclysmic finale that could light up Earth's skies in a way no living soul has ever witnessed. A star like no other. Long ago, in the ancient desert of Arabia, stargazers looked up at Orion and saw a mighty hunter striding across the heavens. They named the glowing ruby star on his upper right shoulder Yad al-Jawza, meaning the armpit of the giant. To the untrained eye, Betelgeuse might seem like just another bright point in the sky, the 10th brightest star visible from Earth and the 7th brightest from much of North America, Europe, and Canada. But to those who study the cosmos, Betelgeuse is a marvel, a star that pulses, dims, and brightens with an erratic rhythm, as if it's whispering secrets about its impending fate. Betelgeuse is a red supergiant, a star so massive that if it were placed at the center of our solar system, its outer edges would stretch beyond the orbit of Jupiter. Its reddish hue, a stark contrast to the bright blue of younger stars, tells a tale of age and exhaustion. Unlike our sun, which will burn steadily for billions of years, Betelgeuse is a cosmic sprinter racing through its fuel in a mere 10 million years. It is a star in its twilight, a giant that has already burned through its hydrogen core, fusing heavier elements like helium, carbon, and neon in a desperate bid to stave off collapse. But the end is inevitable. Betelgeuse is destined to explode in a supernova, one of the universe's most spectacular and violent events, the Great Dimming. In the autumn of 2019, something extraordinary happened. Betelgeuse, one of the brightest stars in the night sky, began to fade. To the naked eye, its familiar glow weakened, and for months it dimmed to an unprecedented degree. Amateur astronomers, backyard stargazers, and professionals alike turned their telescopes toward Orion's shoulder, their hearts racing with a single question. Was Betelgeuse dying? By October 2019, the star's brightness had plummeted, dropping from a magnitude of 0.5 to 1.7 by mid-February 2020. For a star that had long been a reliable beacon in the sky, this was no small change. It was as if a cosmic lighthouse had suddenly flickered, casting doubt on its stability. Social media buzzed with speculation, and astronomers scrambled to understand what was happening. Was this the prelude to the long-awaited supernova? Or was something else at play, a quirk in the star's behavior that held clues to its mysterious nature? The scientific community was abuzz. Telescopes like the Hubble Space Telescope, the Very Large Telescope, VLT, in Chile, and the Atacama Large Millimeter/Submillimeter Array ALMA, turned their lenses toward Betelgeuse, capturing data in infrared, visible, and radio wavelengths. What they found was astonishing. Betelgeuse had ejected a massive plume of gas, a surface mass ejection, SME, far more intense than anything our sun could produce. This event was thousands of times more powerful than a solar coronal mass ejection, hurling material equivalent to 400 billion times the mass of a typical solar outburst into space. The ejected material formed a dense cloud of stellar dust, which, from Earth's perspective, temporarily blocked much of Betelgeuse's light, causing the dramatic dimming. A star in motion. Betelgeuse is not a static giant. It moves through the interstellar medium at a blistering 30 kilometers per second, leaving a trail of shock waves that stretch more than 4 light-years behind it. This motion is a remnant of its violent birth in the Orion OB1 Association, a stellar nursery that also gave rise to the stars of Orion's belt. As Betelgeuse plows through the galaxy, it sheds mass at an astonishing rate, losing about 1 solar mass every 10,000 years. This material forms a nebula around the star, a glowing shroud 30 astronomical units wide, 30 times the distance between Earth and the Sun, and 250 times larger than Betelgeuse itself. At its core, Betelgeuse is a furnace of unimaginable power. Hydrogen atoms fuse under immense gravity, producing helium and releasing the light and heat that make the star shine. But as its hydrogen supply dwindles, Betelgeuse has turned to heavier elements. Helium fuses into carbon, and when the helium runs low, neon reacts with carbon to form iron. Iron, however, is the star's undoing. Unlike lighter elements, iron fusion releases no energy. When Betelgeuse's core fills with iron, it will no longer be able to support its own massive weight. The star will collapse under its gravity, triggering a supernova explosion that will release more energy in a few seconds than our sun will emit in its entire 10 billion year lifespan. A cosmic time bomb. The exact timing of Betelgeuse's supernova remains one of the greatest uncertainties in astronomy. It could happen tomorrow, next year, or in 100,000 years. The star's erratic behavior, its cycles of brightening and dimming, its massive ejections of gas, suggests it is in the final stages of its life. But stars like Betelgeuse operate on cosmic timescales that defy human prediction. Ancient astronomers like Ptolemy described Betelgeuse as ruddy, while Chinese observers noted a yellowish hue, hinting that the star may have been a yellow supergiant in the past. These historical accounts, combined with modern observations, paint a picture of a star in constant flux, its outer shell expanding and contracting every 5 years in a cycle that lasts about 100 days. The great dimming of 2019 to 2020 was not the first time Betelgeuse had puzzled astronomers. Its variability has been documented since the 1st century BC, and its size and brightness fluctuate depending on the wavelength used to observe it. Measuring the star's diameter is a notoriously complex task, as its pulsating nature and the circumstellar envelope of ejected material distort its apparent size. In July 2009, the European Southern Observatory's VLT interferometer captured images of a massive gas plume extending 30 astronomical units from Betelgeuse's surface, one of at least 6 such ejections observed over the years. These outbursts are key to understanding how red supergiants lose mass in their final phases, a process that may hold the key to predicting their explosive end. The dust cloud theory. As astronomers pored over data from the 2019 dimming event, a leading theory emerged. The great dimming was likely caused by a massive cloud of stellar dust. During one of Betelgeuse's violent outbursts, it had ejected a vast amount of material, which cooled and condensed into dust particles. This dust cloud, positioned between Betelgeuse and Earth, temporarily blocked a significant portion of the star's light, creating the illusion of a dying star. By February 24, 2020, Betelgeuse's brightness had stabilized, and infrared observations showed no significant changes in the star's core, ruling out an imminent collapse. The dust cloud theory, while compelling, is just one piece of the puzzle. Betelgeuse's extended atmosphere is a chaotic realm, a spectacle to come. When Betelgeuse finally explodes, it will be a cosmic event unlike any in recorded history. Despite being 640 light-years away, the supernova will be so bright that it could outshine the full moon, visible even during the day for weeks or possibly months. For a brief moment, it will cast a brilliant point of light across Earth's skies, a beacon of cosmic destruction and creation. The explosion will release a torrent of energy, forging heavy elements like gold and iron in its fiery heart and dispersing them into space, where they may one day form new stars and planets. For those of us on Earth, the supernova will be a safe spectacle. At 640 light-years, Betelgeuse is far too distant to harm our atmosphere or life. Its gamma rays and cosmic radiation will dissipate long before they reach us, leaving only the light of the explosion to dazzle our eyes. But the scientific opportunity will be unprecedented. A supernova in our galactic neighborhood would allow astronomers to study the death of a massive star in real time, shedding light on the processes that drive the chemical evolution of the universe. The elements forged in Betelgeuse's core will enrich the interstellar medium, contributing to the cycle of matter that builds galaxies. The legacy of Betelgeuse. Today, Betelgeuse has returned to its normal brightness, but its irregular dimming cycles continue to captivate astronomers. Scientists watch closely, using every tool at their disposal to decipher the star's behavior. The great dimming of 2019 to 2020 was a reminder of Betelgeuse's volatility, a hint that this stellar giant is nearing the end of its journey. Whether it explodes in our lifetime or far in the future, Betelgeuse remains a symbol of the universe's grandeur and mystery. To the casual observer, Betelgeuse is a beautiful red star in Orion's shoulder, a familiar sight on clear winter nights. But to those who study it, it is a cosmic time bomb, ticking slowly toward an explosion that will rewrite the night sky. Its story is a reminder of our place in the universe, a fleeting moment in the life of a star that has burned for millions of years and will one day light up the heavens in a blaze of glory. When that day comes, humanity will bear witness to a celestial event that will inspire awe, ignite curiosity, and remind us of the relentless beauty of the cosmos. Epilogue: a star to watch. As you gaze up at Orion on a crisp, clear night, take a moment to find Betelgeuse, glowing red on the hunter's shoulder. It is a star that has captured the imagination of countless generations, from ancient astronomers to modern scientists. Its erratic pulses, its massive ejections, and its looming supernova make it one of the most fascinating objects in the sky. Betelgeuse is a reminder that the universe is alive, ever-changing, and full of mysteries waiting to be explored. So keep watching, keep wondering, and perhaps one day you'll witness the cosmic light show that will mark the end of Betelgeuse's extraordinary life. A star woven into human history for centuries, Betelgeuse has held a special place in the human imagination, its ruddy glow a beacon for storytellers, poets, and scientists alike. In ancient Mesopotamia, priests charting the heavens saw it as a divine signal, a fiery mark on the shoulder of celestial hunter. The Arabic name Yad al-Jawza, armpit of the giant, evokes a sense of intimacy, as if the star were a living being, its light pulsing like a heartbeat across the vastness of space. In China, astronomers of the Han Dynasty recorded Betelgeuse's yellowish hue, a clue that the star may have been in a different phase of its life thousands of years ago, perhaps a yellow supergiant before it swelled into the red behemoth we see today. These ancient observations, scratched onto clay tablets and silk scrolls, are more than historical curiosities. They are threads in a tapestry of Betelgeuse's story, a reminder that humanity has long been captivated by this star's enigmatic presence. To the Greeks, it was part of Orion, the hunter of myth who chased the Pleiades across the sky. To indigenous cultures, it carried names and stories of its own, a fiery sentinel in a cosmos filled with meaning. Even today, Betelgeuse's peculiar name, often mispronounced as Betelgeuse, thanks to a certain ghostly comedy, sparks curiosity and wonder among those who gaze upward. But Betelgeuse is more than a cultural artifact. It is a cosmic laboratory, a star whose every flicker and outburst offers clues to the life cycles of massive stars. Its variability, noted by astronomers as far back as the 1st century BC, has made it a subject of fascination for generations. The star's brightness waxes and wanes in cycles, some lasting 5 years, others a mere 100 days, driven by the expansion and contraction of its outer layers. These pulsations change its diameter and temperature, making Betelgeuse a shapeshifter in the night sky, a star that refuses to be pinned down. The dance of dying stare in the winter of 2019, Betelgeuse's dance took an unexpected turn. The star, long known for its variability, began to fade dramatically, its light dimming to a level not seen in modern records. From backyards to observatories, eyes turned toward Orion's shoulder, where the once brilliant star now seemed a shadow of itself. By February 2020, Betelgeuse had lost nearly 3 times its usual luminosity, dropping from a magnitude of 0.5 to 1.7. For a star that had shone steadily for centuries, this was a cosmic mystery that demanded answers. Astronomers around the world trained their instruments on Betelgeuse, from the Hubble Space Telescope orbiting high above Earth to the sprawling arrays of the Atacama Large Millimeter/Submillimeter Array in Chile's high desert. What they discovered was a star in turmoil. Betelgeuse had unleashed a massive surface mass ejection SME, a violent outburst that sent a plume of gas and dust hurtling into space. This was no ordinary event. The material ejected was 400 billion times more massive than a typical solar coronal mass ejection, a testament to the raw power of a red supergiant nearing the end of its life. The leading theory for the Great Dimming was both simple and profound. A cloud of stellar dust, born from the ejected material, had drifted between Betelgeuse and Earth, blocking much of the star's light. This dust, formed as the gas cooled in the cold expanse of space, acted like a cosmic veil, dimming the star's glow from our perspective. But the story was far from settled. The dust cloud theory explained the dimming, but it raised new questions about Betelgeuse's behavior. Why had the star ejected such a massive amount of material? Was this a sign that the end was near, or just another chapter in the star's long and unpredictable life? A star's final act, Betelgeuse outbursts, are part of a larger story, one that began millions of years ago in the Orion OB1 Association, a stellar nursery where massive stars are born. Ejected from its birthplace, Betelgeuse now barrels through the interstellar medium at 30 kilometers per second, carving a shock wave that stretches 4 light years behind it. This motion, combined with its relentless mass loss, paint a picture of star in constant flux. Every 10,000 years, Betelgeuse shed the equivalent of our sun's mass, casting off layers of gas that form a nebula 30 astronomical units wide, a glowing cocoon that both shields and reveals the star's inner workings.